Okay, this is the P4 paper from October 2023. It's question number 6, and this is a vectors question. We're going to be looking at a point of intersection. We're going to be doing some work with scalar product. We're going to be doing some work with trying to solve geometric problems in 3 dimensions. And it's quite a tricky one, so let's jump straight in and have a look at it. It says we've got line L1, which has the top equation there, and then line L2, which has the other equation, and it says L1 and L2 meet at the point P, see if we can find the coordinates. So what you'd normally do is put this equal to this. You'd get, 2 plus lambda on the top is equal to 2 plus 4 mu, and 2 other equations, we'd solve them, etc., etc., etc. But have a look at that. It's only worth 1 mark, and all of that work is not going to give us only 1 mark. So have another look at the equations, and we can see, remember what we know about vector equations. This is a point on the line, and then that's the direction of the line. This is a point on the line, and then that's the direction of that second vector. But those 2 points there are the same. So it's almost like a trick question here. If I want to know a point where the 2 lines meet, it is, well, the vector's 2, 3, minus 7, and the point is obviously 2, 3, 2, 3, minus 7. So we start off with a horrible part to this question, and didn't really get much better, but let's have a look at this then. For part A, don't need to show too much for this. You can just say by inspection, the lines meet at, and then the point is 2, 3, minus 7. So part A done. Part B says, given that there's an angle between the 2 lines of theta, can we work out what that angle is? Well, yeah, we should be able to do that. In fact, sorry, no, it doesn't say that. It says, can we find the value of cos theta? So all the way through this question, there are little bits to try and catch us out, and give that as a simplified fraction. Okay, yeah, well, let's do that then. Again, part B here. You hopefully know that A dot B is equal to the modulus of A modulus of B cos theta. So we're taking the directions. This one's going to be A, this one's going to be B here. So if I do that, then I'm going to get that 1, 2, 2 dotted with 4 minus 1, 8 is equal to the modulus of those 2. Well, the modulus of the first one is the square root of 1 squared plus 2 squared plus 2 squared, and the modulus of the second one is 4 squared plus minus 1 squared, but I'm just going to write 1 squared there, plus 8 squared cos theta, and then tidy all of that up. So the left-hand side works out to be equal to 18. The right-hand side, those 2 square roots both work out to be equal to 27. So we get 18 over 27 cos theta. So cos theta is 18 over 27, but 18 over 27 is the same as 2/3. Let's just go back and check. So yeah, we've done that properly, and we've got it as a simplified fraction. And then it says, right, point Q lies on L1, lambda is equal to 6. R lies on L2, such that the triangle QPR is an isosceles triangle with PQ equaling PR. And then it says, can we find the exact area of that triangle? Let's try and draw a quick sketch of that to just show exactly what that's saying. So if I've got my axes, don't really need the axes in, but we'll just put them in. Got the axes here then, so I've got some point P, well, in fact, let's draw OP up. We've got P, which is here. I'm going to say this is the line L1 then. We've got Q, which is on that, and then we know we've got another point here, and R would have to be the point then. Theta was the angle between them, remember, such that this one is equal to this one, And what we're trying to do is to then work out the area of this isosceles triangle. This is L2 here. Let's get rid of the shading in. And that's a very quick version of the diagram, but that's what they've told me that we've got to do. And we know that if I want to work out OQ, so I can start adding things. I might do it in a different colour actually. Put OQ on there. If I want to work out OQ, then that's when lambda is equal to 6. So if lambda is equal to 6, then OQ is going to give me 2, 3 minus 7 plus 6 lots of 1, 2, 2. Okay, so that then works out to be 8, 15 minus 1. It's not OQ that I want though. Let's just tidy this up. It's not actually OQ I want, it's PQ I want, because PQ is one of the lengths of my triangle. So PQ, how do I get PQ? Well, looking at the diagram there, PQ is PO plus OQ, isn't it? And PO is minus P. So PQ, up to you how much of this you want to show. Obviously, it's a long question already, but PO would be that. So in other words, you could either do it as 8, 15 minus 1 minus 2, 3 minus 7, or you can do it as minus 2, 3 minus 7. Just think about the way that we're setting this out. So it's minus that plus the 8, 15 minus 1. So that works out to be 6, 12, 6. Okay, so if we know that PR and PQ are equal to each other, then if we can work out the length of PQ, that will give me the length of PR, and I'll have two sides of this triangle. So the actual length of PQ, modulus PQ, that's just the square root of 6 squared plus 12 squared plus 6 squared again. So that works out to be equal to 18. So if I'm now looking at this triangle again, working out the area of this, if I call this B and I call this C and I call that angle A, it's half BC sine A, isn't it? It's half BC sine A when I'm trying to work that out. So I'm going to get rid of all that and then just explain that again to the examiner. Get rid of that and that. So if we say the area of PQR is equal to half BC sine A, which is a half PQPR sine theta, which is a half 18 times 18, and I now need sine theta. Well, if we go back here and we know that cos theta is equal to 2/3 up there, to work out sine theta, really quick. So for theta, we know that cos theta is 2/3 adjacent over hypotenuse using Pythagoras. I'm not going to spend ages over that. That would work out to be √5, and so sine theta then would be opposite over hypotenuse, would be √5/3. So then tidying all that up, half times 18 times 8, that makes 54 √5 as the area of the triangle PQR. Right, on to the last part, which again is a tricky little thing here. So what it then says is, can we find the coordinates of the possible positions of R? So we've got R as being there if sine theta equals 3/5. That acute angle there, but there's also the possibility of sine theta equals 3/5 if we had R the other side. So if we had R being, let's just put it on here first of all, I'm going to call it R dash. R dash could be up there somewhere, where again, same length the other way there, but then this time we've got that the angle between the two of them is this acute angle there, alpha, that acute angle, but sine alpha and sine theta would work out to be the same as each other. So already a little bit complicated with what we're saying. That's what I want to be able to work out, r dash or r. But even let's work out r first of all. So if I want to work out r, just looking at that diagram, we can see that OR is going to be OP plus PR. Well, I want to work out, sorry, PR is the one I want to work out. I want to work out what PR is, but I know that PR, so for PR, what's happened there with my pen? But I know that for PR is equal to mu lots, I'm going to say mu lots of 4 minus 1 eighths, but I want the modulus of that, which is going to be the modulus of this thing, to be equal to 18. So I'll be able to work out what that multiple is, what mu is going to be there. How am I going to do that? So I'm going to say the length of, well, let's write it out first of all. So that's 4 mu minus mu, 8 mu, that's PR. And so the modulus of PR then is the square root of 4 mu squared plus minus mu squared, well, that's that, plus 8 mu squared. What does that all work out to be? Well, that works out to be equal to 16 mu squared plus mu squared plus 64 mu squared. So that all works out to be 81 mu squared, and that's going to be equal to 18. Square root of it is going to be equal to 18. We know the length of that is going to be equal to, 18 squared. That's square root of that is going to be equal to 18, or in other words, that's going to be equal to 18 squared. Let's put that in for that bit. So that means that mu squared works out to be 18 squared over 81. Mu squared works out to be equal to 4, which means that mu works out to be equal to 2. Wow. Okay, so much work involved in this question. So now if we go back to the original part up here, then we've got that the lines we're looking for, OR, is going to be 2, 3, minus 7, plus or minus that mu, because the plus will go in one direction and the minus will go in the other direction. I don't know how many of you are still with me at this point. If you are showing a lot of resilience here. So OR is going to be equal to 2, 3, minus 7, and then it's either plus or minus 2 lots of 4 minus 1 8 there, and then we work that out. It either works out to be equal to 10 1 9, or it works out to be equal to minus 6 5 minus 23 there. Now what did they want? Did they want the vectors, or more likely the coordinates? So yeah, the coordinates of that. So that means that R and R dash respectively are 10 1 10 1 9 and minus 6 5 minus 23. Now I would not worry too much if that last part has caught you out. That's a very, very tough question, but the rest of it you should be able to work through and just see how difficult these vector questions can be and how sneaky they can be with some of the little parts that they do to it. But yeah, you might need to watch that video more than once. Hopefully most of that makes sense to you.